ओके, अभी तक हम लोगों ने डिस्कस किया है मेजरमेंट के बारे में, बट लेट मी टेल यू, none of the measurement in this world is 100% correct. Even the scale which you use for measurement of length, that is also not 100% correct. So today we will discuss a very important topic, error in measurement. सबसे पहले समझें कि इसको पढ़ते क्यों है। मान लीजिए आप एक कॉन्ट्रैक्टर हैं और आपका बिजनेस है पाइप्स बनाने का, और आपको कोई कॉन्ट्रैक्ट मिला कि आपको 1000 पाइप्स बनाने हैं विद 10 सेंटीमीटर इंटरनल डायमीटर। ठीक है, आप बोलेंगे ये तो पॉसिबल ही नहीं है, क्योंकि एग्जैक्ट 10 सेंटीमीटर इंटरनल डायमीटर का पाइप तो सिर्फ एक ही बना सकता है, वही भगवान बना सकते हैं, इंसान नहीं बना सकता एग्जैक्ट 10 सेंटीमीटर इंटरनल डायमीटर का। तो फिर आपको जिसने कॉन्ट्रैक्ट दिया है, आप उससे पूछेंगे कि मुझे कोई टॉलरेंस लिमिट तो दो, मतलब मेरी गलती किस हद तक माफ है। मान लीजिए मैंने 10 सेंटीमीटर का इंटरनल डायमीटर का पाइप बनाना था, मान लीजिए मैंने 12 सेंटीमीटर का बना दिया, तो वो तो एक्सेप्ट नहीं होगा। और आप ये भी कह रहे हैं कि सर none of the measurement in this world is 100% correct, so there must be a tolerance limit in between, your design must be lie. Okay, so अगर 10 सेंटीमीटर इंटरनल डायमीटर का पाइप है, तो लेट्स से आपको कंपनी जो आपको कॉन्ट्रैक्ट दे रही है उसने कुछ टॉलरेंस लिमिट दिया, दैट 10 प्लस माइनस 0.2 सेंटीमीटर। ओके, प्लस माइनस का क्या मतलब है? इसका मतलब है कि अगर 10 में से 0.2 माइनस कर दे तो मतलब 9.8, और अगर 10 में 0.2 ऐड कर दे तो 10.2। मतलब अगर आपका जो पाइप है 9.8 से 10.2 के बीच में लाई करेगा इंटरनल डायमीटर, तो वो एक्सेप्टेबल है, नहीं तो वो एक्सेप्टेबल नहीं होगा। तो ये टॉलरेंस लिमिट है, इसलिए हमें ये डिस्कस करना बहुत जरूरी है कि एरर को फाइंड कैसे करते हैं। तो सबसे पहले तो समझे कि एरर है क्या। Difference between true value and measured value of physical quantity is known as error in measurement. So like I told you to measure length of this marble and its original length in 10 centimeter, let's say, and you measured 11 centimeter. Then what is the error? 1 centimeter. If you are measuring 1 centimeter more, that is 11, then there is a positive error of 1 centimeter. And if you are measuring 9 centimeter, then there is a negative error of 1 centimeter. Now, here is the simple relation. Error is true value minus measured value. So error can be positive, can be negative. Okay, it can't be zero. That is not possible. First, we will discuss systematic error. What is systematic error? Let's take an example. That you all have a general scale that is of 15 centimeter. Let's say it is cut off from its Let's say it is cut off from 0.2 millimeter. Now this scale will always give you positive error. Okay, this scale, if it is cut off from the edge, it will always give you positive error, and positive error must be subtracted from the measured value. So if the scale is cut off at the edge, it will always give positive error. So this is a systematic error. Okay, it can't give negative, it will always give you systematic error. So the error which tends to be in one direction, either positive or negative, is known as systematic error. Second is random error. What is random error? Let's say the error, basically random error is the error which is dependent upon physical conditions, yani humidity, pressure, temperature. Okay, what happens is when it is very hot in summers, your scale will increase by a very small value, let's say 0.00001 millimeter. Okay, then also it will give you an error. And maybe in winters your length of your scale is swing, then also it will give you some error. So these type of errors come in the category of random error. The error which can tend to be in positive as well as negative direction is known as random error. Okay, and the third is zero error or instrumental error. This is the error basically which is installed with the measuring instrument at the time of manufacturing. Okay, अगर कुछ बनते टाइम इंस्टॉल हो गया है error, तो वो स्केल तो हमेशा आपको गलत ही बताएगा, गलत रीडिंग ही देगा. Okay, that error is known as zero error. The error installed with the measuring device is known as zero error. It can be positive or negative. यहाँ नोट करके कुछ पॉइंट्स लिखेंगे, बहुत इंपॉर्टेंट है. Positive error must be subtracted from the measured value. Negative error must be added to the measured value. Combination of errors. What will happen if two readings are added or subtracted? So first one is error in a sum or difference, yani addition or subtraction. So let's say x is a measurement, okay, जो a और b दोनों को ऐड करने के बाद बनता है. तो यहाँ मैंने क्योंकि एडिशन और सब्ट्रैक्शन दोनों डिस्कस करना है, इसलिए मैंने प्लस माइनस दोनों साइन दिया है. अब लेट्स से डेल्टा ए जो है इज एरर इन ए, इसे डेल्टा बोलते हैं. डेल्टा डेल्टा का सिंबल है ये ट्रायंगल जैसा. इसका मतलब होता है चेंज, यानी एग्जैक्ट वैल्यू तो ए थी लेकिन उसमें कुछ एरर था डेल्टा ए, मे बी पॉजिटिव या नेगेटिव कुछ भी हो सकता है. डेल्टा ए इज एरर इन ए, लाइकवाइज डेल्टा बी इज एरर इन बी, डेल्टा एक्स इज एरर इन एक्स. तो हमें फाइंड क्या करना है कि अगर ए में एरर डेल्टा ए है, बी में एरर डेल्टा बी है, तो एक्स में कितना एरर होगा ये हमें फाइंड करना है. तो हेंस वी कैन राइट इन द फॉर्म ऑफ एरर्स x प्लस माइनस डेल्टा x. यही वो टॉलरेंस लिमिट है जिसकी मैं बात कर रहा था, प्लस माइनस डेल्टा x इक्वल्स टू a प्लस माइनस डेल्टा a प्लस माइनस b प्लस माइनस डेल्टा b. ओके, सो a प्लस माइनस b एक चेंज कर लिया, वैसे ही डेल्टा a प्लस माइनस डेल्टा b को एक जगह कर लिया. अब ध्यान से देखिए फर्स्ट इक्वेशन में x जो है वो a प्लस माइनस b के इक्वल है, तो x से ये a प्लस माइनस b कैंसिल हो जाएगा और ये डेल्टा x आ जाएगा प्लस माइनस डेल्टा a प्लस डेल्टा b. एक बार ध्यान देने की जो है कि दो मेजरमेंट्स चाहे वो ऐड हो रहे हो चाहे वो सब्ट्रैक्ट हो रहे हो, जो एरर है वो हमेशा ऐड होगा. ये बात याद रखें, ये किसी भी कंडीशन के लिए तय है कि एरर हमेशा ऐड होता है. We will take the example of it. Like two resistances are given, R1 and R2 with error limits, and you have to find equivalent resistance in series with error limits. Then we know that for series combination, R equivalent is R1 plus R2. Okay, we will add here 200 plus 300 is 500. Then delta R equivalent is delta R1 plus delta R2 from this equation. Then delta R1 is 3 ohm and delta R2 is 4 ohm and delta R equivalent is coming 7 ohm. Then R equivalent can be written with error limits is 500 plus minus 7. This is without error limits and this one is with error limits. Okay. Second type is error in a product. Okay, it's very simple. Like now you are going to multiply two things. Okay, so x is equal to a into b. Now we will consider same as delta x is the error in x, delta a is error in a, and delta b is error in b. So we can write each term with its error limit, like x plus minus delta x, a plus minus delta b, a plus minus delta a and b plus minus delta b. If you will take x common, it will be written as 1 plus minus delta x by x. Hence, you will take a common here, you will take b common here. Okay, then you can write it as ab into 1 plus minus, you can multiply these two terms. Okay, so 1 into 1 is 1 and 1 into delta v by b is delta v by b plus minus delta a by a into 1 is delta a by a and delta a by a into delta b by b is this term. Okay, so here as delta a is a very small quantity and delta b is a very small quantity, and if they will multiply they will be smaller again, so we can neglect this. Okay, it is approximately 0. Okay, then x is equal to ab, so x and ab will be cancelled out. Okay, 1 and 1 will be cancelled out. This is 0. So we can write delta x by x is equal to plus minus delta a by a plus delta b by b. Okay, so it is slightly different from the last case. Here it is showing a relative error. Okay, a relative error in x is equal to plus minus a relative error in a plus a relative error in b. We will discuss a relative error in details. Okay, we will take example here like length and breadth for a rectangle is given with error limits. Okay, find area with error limits. So we know that area is L into B. Okay, so what you will do, you will find area 100 into 200 is this much centimeter square if they are given in centimeter. Now delta A by A is plus minus delta L by L plus delta B by B. So delta A by A is plus minus, what is delta L? 2 upon L is 100 plus delta B by B 4 upon 200, and if you will calculate it will come like plus minus 0.04. Now you know A, from this equation you can put value of A. So here it will come 800 centimeters square. Now area can be written with error limits as it will be 20,000 plus minus 800 centimeters square. Okay. Next is error in a quotient. Quotient yani division. So here we have taken x is equal to a by b. Now we will write each term with error limits. So x will be written as x plus minus delta x, a plus minus delta a, b plus minus delta b. Now we will take a common from here and b common from here. If you will take a common, then it will be 1 plus minus delta a by a. Here if you will take b common, b into 1 plus minus delta b by b. Now this can be written as same a by b, a plus 1 plus minus delta a by a. This whole term, if you will take up, it will be raised to power minus 1. Now applying binomial concept, this minus 1 will be multiplied here. So this will be same delta b by b. Okay, plus minus will be minus plus or plus minus, not a problem. Okay. Now here if you will take x common, so it will be x into 1 plus minus delta x upon x. Okay, here it is a by b. The same term x will be cancelled out with a by b because of this, and now 1 plus minus delta x by x. Here you will multiply the both terms, 1 plus minus delta b by b plus minus delta a by a plus minus delta a delta b upon ab. 1 will be cancelled out by this, and this is very smaller term, that is approximately equal to 0, so we will ignore it. Delta x by x will be now plus minus delta a by a plus delta b by b. Here you can see one thing, that in last case when we were discussing error in a product, the output was same. Okay, so remember I have told it many times that errors are always added. Okay, now we will take a question for it. Like a voltage is given as 200 plus minus 4 volt and resistance is given as 10 plus minus 2 ohm. Now we have to find current with error limits. So we know that current is V by R. So V is 200 upon R is 10. It will be 20 ampere. Now we have to find error. So applying this concept here in this term, delta I by I is equal to plus minus delta V by B plus delta R by R. Now delta I by I, putting value of I is 20 here, equals to plus minus delta V 4 upon 200 plus delta R by R is 2 upon 10. Okay, so here it is. Now delta I upon I is equal to plus minus, here we will calculate it, 0.02 plus 0.2, we will add them 0.22 and 20 will be multiplied here, giving 4.4 ampere. Now current can be written with arrow limits as 20 ampere plus minus 4.4 ampere it is. Next is error in a power. So x is equal to a raised to power n. Okay. Now we can write them with arrow limits. X plus minus delta x is equal to a plus minus delta a raised to power n. Here you will take a common, but as power is n, a raised to power n will come here. 1 plus minus delta a upon a raised to power n. Now again applying binomial, n will be multiplied here. So 1 plus minus n into delta a upon a. X is a raised to power n, so it will be cancelled out. If we are taking x common here, 1 plus minus delta x by x, okay, x will be cancelled out. 1 will be cancelled out from here. So delta x upon x is equal to plus minus n times delta a by a. So here you can also see that error is, or here also it is added. Okay, n times error is added. So remember, error is always added. Next is error in a product of powers. That is very easy. Like x is written as a raised to power l into b raised to power n upon c raised to power m. Now it is very similar to the previous one. Delta x by x with the relative error in x is equal to plus minus L times delta A by A into n times delta B by B upon m times delta C by C. Here we have used error in a product and error in a quotient, both the concepts. Okay, so we all know it already, so we can use it directly. Okay, Now there are some important terms in errors which will help you in solving many numericals. Okay, so first one is mean absolute value. That is very easy. That is average of all the measured values of a physical quantity. Like say, if I will say you that measure its length, okay, and like its original length is 10 centimeter, and sometimes you measure like 10.1, sometimes you measure 9.9. So what we are doing here, we are taking average of all the measured values, okay, so that is mean absolute value. Okay, and if you don't know its original length, then this average will be the correct value for you. This will be true value for you. So it is also known as best possible value or the true value or the default value. Okay. Okay, next is mean absolute error. Why? Because in every measurement there is an error. Likewise, when you are measuring at 10.1, there is a positive error of 0.1. Likewise, when you are measuring 9.9, there is a negative error of 0.1. Okay. So, average of all the individual errors is known as mean absolute value. So, error in A is delta A1, error in A2 is delta A2, error in AN is delta AN. But we are taking here mod value. Yani negative will become positive. Okay. Upon N. Okay. Now, how you will find delta A1? Because AM is true value for you, you will decrease A1 from AM. So, AM minus A1 will be delta A1. AM minus A2 will be delta A2. Likewise, you can find each term. Okay. Now, next is relative or fractional error. Relative meaning how much error in this, the whole term. Okay. So it is very simple. Delta AM upon AM is a relative error. Likewise, you can find percentage error. Delta AM upon AM into 100. Okay. Must remember the formulas in the boxes. Okay. Now, go for NCERT example 2.7. Try to do it by your own. Then after you can see the solution. Okay. There are 5 times given different. Okay. You can find here mean absolute value like this divided by 5. It will give you 2.62 seconds. Now, you need to find mean absolute error. What you will do? You will find delta A1, delta A2, delta A3. How? There is mean value minus each term 2.63, 2.56. Someone will come positive, someone will come negative. Not a problem because we are taking here mod value. So negative will become positive. Okay. So delta T min, when you will add up these all divided by 5, you will get 0.11 seconds. We are not taking minus values. Okay. Now delta A relative error will be delta Tm upon Tm. Here it is Tm. Okay. Mean value. Okay. Now percentage error will be 0.11 delta Tm upon Tm into 100. Approximately it will give you 4%.